Assalamu alaikum. My name is Fatma Nazreen. I'm doing mechatronics engineering this master. This is project is about this is a project related to the subject of this master microcontroller embedded system. We select the we select the topic for this in this subject is we make a line forward report. Our project is about all about is line forward report. In this report, we explain everything is about the line for report, how to make, how to integrate the sensors, and how to detect the path and how it's working. All the things about how the line for report we discussed in this video. So first of all, we introduce our group members. Fatma Rashmi or Madhya Fayaz, Waisha, Hassan Majid, Hassan Hafiz, and we'll be waiting, as you know, if all of you are microtraining students, and our supervisor is Sir Umar Farooq. Now we will discuss about this software approval. We will see declarations. You know. Now the first of all main the thing is about the abstract. What is the objective of this project? Yes, you know abstract. So the abstract of our project is about we make a report can be fixed as mobile reports. As you know, the mobile reports are reports which mobile based which make the report more freely at the moment environment. One of the advanced mobile robot in the line for robot is basically a robot which follow a particular path, and the path maybe we take a black and white. We take the black line like how we paste the black line on the floor, and then we run the line for robot, and then we take that follow the trajectory path and a particular path which is only on the black he's it's only black line. uh, we also make we can also make the white flow but we visible of a magnet. Okay, now this report is integrated with the more sensors for take the all information and movements. For the information and movements, we use the sensors to charge the voltage sensor, speed sensor, obstacles, and store them, and then we all get the data from this that detects the data. Sensor will get the data detect and take the data and then store in them in a SD card. SD card and its application starts from the basic DOM is used to industrial use. The use of line forward robotics is vehicles that transport the material from one place to another place in the industry, and the robot's movements completely depend on the track. You make the track in different zip line, straight, and you make circular. You make any track. If you are integrate everything you are doing as good, you integrate the sensor, uh, you can set all the sensor in a displacement and in the correct way, and you upload the code is correctly, then you can easily your robot is more convenient on the given track. Maybe circular, maybe as rectangular, maybe as straight. Now we will discuss. This is the table of contact. In this table that we discuss, these are the chapters that we will cover in this report, and we explain the main topics in this chapter. That is main topics that cover the working of plan for a report. So first of all, the proposal, project plagiarism, and chapter one is project plagiarism, the proposal, and concept design, and reconstruction cost effective collection of data support various types. And the work breakdown, structure, estimates, budgets, and charts, team members, roles, and details. extracts and all this chapter 2 is started, and then in which we discuss about the sensors that we use over the pin configurations, Arduino Omega pin configurations, ESP32 and configurations, and line 8 and motor drivers. So all these sensors, all these motor drivers and gears motors, that the things that we used in the project already we discussed in the chapter 2. Now the next is chapter 3 is about all about the product design, how to design base basically. Well, chapter 4 is the mechanical design, and the chapter 5 schematic, chapter 5 software and hardware and theoretical and schematic components. Also about the PCB design, we make a PCB also, and the integrations of sensors. We can write the codes of our sensors. Okay, in chapter 7 we simulation of final integration, and then chapter 8 we have the testing hardware implementation, and then the chapter 9 is about the system test phase, and the chapter 10 is about the project management. Now here in the last one is uh his reference and that. Okay, now I'm here to discuss about the chapter 1, which is a project planners. Okay, first thing is about the proposal. What is a project? Our proposal is to design a line for a report that's cover a given path in minimum possible times. While being a cost effective also, a microcontroller binary system for a line for reports can be called in binary paths from point 1 to A to B, point B upon reaching the point P, which is the T2 instructions, which all the blocks, lines and stop, which is to use IS sensor which detect the line and actual brush and control the working of field. And the main concept of our project is about the path which are visible like a black line or white surface. The high concentrated cultures, this can be visible like a magnetic field, definitely to kind of robots to reasons in the line of the infrared eyes. Installed on the robot, and the data is transmitted to logical circuits. Hence, the logical circuit is going to design the proper command and they are sent to them, and then the pass will be followed by the line for the report. In our report, we discuss about the process of a design implementation and how to implement the sensors. So all the things we are implementing in the report we can explain here. Our the testing of a small report, line for report design, and then we basically attributes our projects by we use the first thing is the real limit construction. This time is the cost and last cost, suitable cost, we can factor not factor the cost factor, and the collection of data of various types. Design, first thing we design, we'll have done our designs, the working on three, we can do working on three attributes of our projects. First we explain how the real constructions. In the real level construction we had the using the button of on and off reports, and we can implement on the circuits, we implement the PCB. On we make a circuit on breadboard, yeah, we make implement a circuit on a PCB. We make we will implement the circuit on PCB, not a breadboard. And the cost effective Brazilian components of from wholesalers, and using the implement components to complete the project. The other thing is a collection of data for various types. Uh, these are current required motors, speed required cans, voltage required, weight of just pistol that with the varies. And the other thing is IR sensor lighting is checking for working, and these are the collection data varies. They think it's a work that all the work is so much work, so that's why we distribute in her group's members, and we distribute in a phase. We do this work in before the midst and after the midst. In phase one, we are doing in all the works in phase 5. Like phase 1, we doing the simulation on protest programming. Phase 2 is PCB designs, and phase 3 is ordinary components. Phase 4 is implement of blackboard. Yeah, in the PC, we are implementing the hub design on PCB. Phase 5 is complete project and final testing. Estimate of our budget is about. Now here these are the estimate budget, or this is all the budgets that's we done in our projects. We tell we can using these components, and we can buy these components from shops, and then these are the prices. We take or we can buy these components from laptops and from Dras. So these are the prices. And chess we will two tires, two motors, about maximum this the price of all these things are to 1200 to 1500. Wires male to female to male, male female to female is 400. Sorting wire is 200. But we yeah, sorting wire is 200, and we take the solder from the project lab. Sticker sheets and 120, 150, and ultrasonic sensor that remains is 250, and cell holder 180 to 200. We using the wearable. We're not using a wearable. We are make a PCB design. So we take the sheet of PCB. We take the copper sheet in which we would make a design with sticker. We have a sticker. We make it's a design on the first of all we print out the circuit, and then we paste on the PCB, and then we press it, and we then the PCB is then we don't, remove the sheet, and then we drill it, and then solder all this, and we attach the components, and then we make a PCB. I'll explain it in the next slide in chapter number 5. Uh, the double side straight tape 100 to 150, and we use a 5 sensors. With the price of is one sensor is 180, and we use the 5 to multiply 180 by 5. And the Alto 98, we use the motor driver Alto 98. This is which was the A350 to 70 maximum. Dino Mega, which is 2200. PCB, we make a PCB. This is the PCB is 800. Breadboards, we are not using a breadboard, but we carry on because we first of all we check the circuit on the breadboard. 140 to 400. So battery cells, which is to 10. LCD, which display is 650. SD card module to storage the data for storage data is 200. Servo motor before use the movement of axis of electronic sensor, which was 280. Electronic sensor holder also for which we attach the ultrasonic sensor 70 to 108. Polish movers as 90 for the PCB to remove the copper wire, and to get copper, so that's good. Our total estimate is 3,000 to 900. Again, short. Now we explain the Gantt chart. We can work in how many days? We can work on in 2 months. These are the in the end of November, 25th November. We were working on the schematic, and we then we equipment using as 27th November, and the 30 we can implement the circuit on the breadboard board implementation, and then we check the circuit working properly. Then we make the PCB. Then we can print the PCB design on a Proteus software, and then we can when we print out, and then we buy the implement on the PCB on 13th December, and then where the we raise the and 17th December we added analytical and final testing, and 20th December we make the we submit the report. Not a submit a report, we make the working on a report writing as and the and 2 Jan we submit the report of this project, submitted this project report. Now this is role of team members and real details. The team member Madhya Fiaz is working on uh, buying components. He is buying the component online on Dross, and he write the code, schematic simulation on Proteus, working on and hardware on Revit report making. And Vadisha is working on the writing code. He's also work on we are working code in different we say that in a different thing we write a code that's in different components. IR sensors like electronic sensors, different components want to code, so we write a code different, we write a code to different members for a different components. Technical work, assembling hardware, debugging, updating code time to time, and report making. Ehsan Majid is buying a components also from shop, and schematic simulation on PCB making robots. He's working with me. Fatma Nazir. I'm which is I am I'm working on the schematic simulation of PCB design on Proteus, and we write the code on the sensors, which was showing sensor, and we also working on the report making. Uh, the blue line is showing us that these are the right with me, and Ahsan Hafiz, so working upon schematic simulation and PCB making and report making. We are all the working equally in this report and in this project, and the colors we hear the colors of names mean it show that the in this report we see a different you see a different colors, so it means that the colors belong here this show the this is working of that person, the colors show that the that person. So that's why orange color is show that the working of Madiha, and in the report red dark red color shows the working this right, and the workers on it is Warisha. Another one is the green line is green color is show that Sama sheet, and dark blue color is me. It's I'm working on it. I'm the that topic and our project, and the Ahsan Hafiz is black, dark black, light black. Sorry. These are the work distribution of phase return instructions. We also explain in the upper also. These are the breakdowns of work structure. Now in the chapter 2 we will discuss about the introduction. We also explain here we make the report is coming automatically. The main working of a project, main working of the report is that gradually detect the path and move the straight forward. So he starts working when he sense the something decides and to work according to the conditions, stop and how now other conditions sense. So we can say that the robot and the replace human beings. That's the working phenomena is human to do. So now the robots are maybe fixed on mobile robots. Line forward robots, one of the advanced mobile robots as we make the base movable and it can be moved from one place to another place. The line forward robot is particular path trajectory and decide as it choose to interact with obstacle. Usually the path is a black line. We take the path is black line. So he when we move the robot in on the path, then he only move on the black line, not move on without the path. So the main objective of the project is the robot is move on a black path, not to move to and for, and we say that not to move without a path. So this is a literature view in which we explain our ultrasonic sensor. Ultrasonic sensor is it advice that sense the ultrasonic energy, and ultrasonic sensor here explains the low repulse in controlled manner. And when the signals hit obstacle, when we discuss the history obstacle, the signal is back and receive this ultrasonic sensor. In our project, the obstacle when we report the movie and we see any obstacle, anything in front of it, so that's where we detect it and then change its direction, and they move on a like keep on up on her path. So in the we explain in the ultrasonic sensor there are four pins. One is the ground, one is a VCC, and the other one is trigger and echo pin. Now here this is ultrasonic sensor. We explain here the three pins. Now this is the pin configuration. VCC is means when the ultrasonic power is 3.57, typically 5 volt. In more, if we apply a more voltage 5 volt, more voltage applied, the more than 5 volt, then the sensor is damaged. The trigger pin has for an input pin, and echo pin is working as output pin, and ground pin is connected to a ground of the system. So these are the explanation of about the HCSR04 ultrasonic sensor in the feed formats, which are PCC, trigger, and echo, and ground specifically. This is sensor is used in a many application for a measuring distance or sensing the object is required. So here when we make the code of the code of the electronic sensor, then we use this formula for the sensor working simply high formula distance equal to speed multiplied by time. So ultrasonic sensor actually transmit ultrasonic waves, and this waves is around here when we get the objective parameter. So servo motor, here, this is a servo motor. Is a type of a motor that can rotate with a great precision. Servo motors is more is a 180 or 190 90. He rotate in 180 degree. Maximum is 180 degree, and him is 90 degree. So servo motor is just as a DC power supply, and also we also call the servo motor as a DC servo motor. We use is for the move the we attach the ultrasonic stand on the servo motor, and then we attach the ultrasonic sensor, and when the servo motor is moved, the ultrasonic sensor move left to right and left to right and detect the obstacle. So that's why we use this servo motor, and this is the information about the servo motor. And then here this is explained here the pulse of a servo motor that we will use. PWMR, PWM angular rotation of a servo motor is 0, 90 degree, and 0, 80 degree and 180 degree, and total 20 milli per second. So this is the graph of the servo motors that we explain here. The pin configuration of servo motors, these are the pin configuration. Brown is for the ground, and red for the power spec 12, and orange fiber is a PWM that gives the single of the wide red driving motors. Arduino Mega, that's the main controller. That is the microcontroller we use and the project, and the all the computer working on for this uh, um, this controller, because we upload the code on this controller, and then we all this working on it. Now here with these are the estimate budget, or this is all the budgets that's when we move the report in on the path, then he only move on the black line, not move without a power. So in the we explain in the electronic sensor there are four pins. One is the ground, one is a VCC, and the other one is now here we are discussed about the Arduino Mega. Here you tell me about that this is the controller. Now we upload the code on this controller and then where our project remove is working on the, our project is working on all about of our code. So that we upload on it. We explain what is Arduino Mega and how it's working and how to is working and which components is attached in this which component is embedded in this circuit. So Arduino Mega is microcontroller based on the Atomega 256, and this is we'll say that the Mega 36250 will give you हमारे पास is a controller, and then it has a 54 digitals and inputs pin and outputs, in which is the 15 are PWM outputs and 60 analog inputs and 4 USART, 16 megahertz crystals, oscillators, and USB connection. The main is a power jack. Also ICSP header and result button. It contains everything needed to support the controller, and we connect the PC computer with a PCB cable, a power AC to DC adapter, and the battery is started. The Mega 2560 board is compatible with most fuel design with the UNO. So these we explain here. This is the in here we attach these are the pins, digital pins and ports digitals, and these are the analog pins. These are the analog pins. These are the digital pins. That's the transistor, the grounds, voltage, resistors, and this is the jack USB. This is a jack and USB jack is also here. So the different components that is embedded in this controller. So this is a pin configuration. Here we see this here in this picture we can attach the pin we attach the wires according to this configuration of controller. So next we explain here the robotic chairs. There were two wheels and the DC motors. We attach the wheels with the two DC gears, geared motors. We use the geared motors. So this is the package of contain here with these are two more DC motors and the two tires. We attach the tires with the DC motors, and this is the base, the main base. We make the base on it, base, and then we attach the motors with the glue gun, and then we have the tires we can set on the this in the turn in the motor. So this is the package contains, so that is in your faster regulation motor and in lower altitude. So here the ESP32. The other thing is ESP32, which is the chip of our department. We have to call the embedded system. The main purpose of ESP32 is module developing about a chip of our ESP32 is mainly is for detect the data from Wi-Fi and Bluetooth. We can transfer the data in the chip. We can control the motor. You control over the ESP, Bluetooth, yeah, Wi-Fi. So these are the about the ESP. This is the configuration of a ESP32, and this is a board headphone and the USB pin. Enable reset pin. So this is the ESP warm M2, and we this is the power supply here apply, and we this is the USB USART bridge, and we here is the Wi-Fi also it's also attached with here, which can we transmit the data and then we check it and then working on it. ठीक है, now the other thing L29 more L29H and motor, alternate motor drivers is for working of a motor DC motors. So here these are the outputs and ground and voltage 12 volts and 5 volts. So that's why we apply on 5 volts maximum 12 volts. So this is image. So we attach here in the output, we attach the motors, or motor A, and and then on the right side, on the left motor here we attach here, and there we attach a right motor, a right side motor. So here we attach the two motors with the tires. So TC gears motor we explain here as it's working as a DC gear motor. This is a TC gear motor, that positive and negative. Then we attach on the in the motor drivers. So in the next slide, we see a TCC and ISA sensors. We use the ISA sensor for detect the path of when we the IR report, when the line forward report is working, and then he detect the path for the IR sensors. So the encoder, the encoders mainly is working as like is electromechanical device that convert the angular motion in the position of rotatory shaft into angular digital code that represent the motor position. It can be used for the motor speed and position feedback for applications that include the servo motor loop control loop of lights. So now here, this is the SD card module we are used here, that is store all the data from come from a sensor of ESP3, and all the data is going and store in the SD card. SD कार्ड डेवलपमेंट इजी टू फॉर एक्सेस द SD card पे इजी माइक्रोचिप adapter लगा होता है and it's easy to ways to more the SPI interface and the maximum the voltage on board is 3.3 volts was regulated to provide us. So this is LCD for display the data. When is obstacle was come in front of a line for remote and it show here in the LCD, uh, that scale the obstacle, so the obstacle string. So this is a pin configuration of a LCD. We follow this pin configuration. We follow the configuration of LCD according to the given the table, given the picture and the diagram and the PDF. Given the PDF of MAM we can set all the configuration of set of the wiring of LCD with Arduino according to MAM PDF, MAM-ish PDF. Now this is a current sensor that can detect the current incoming the how much current is incoming the line power reports. So here this is a voltage sensor working probably for varying voltage, and there's it may be the right terminal is connected input voltage and 5 times smaller. So now it's the potential meter is the increase and decrease for this is a potential gradient, and these are the three pins we are working on it commonly. So here now the main things we here come flow chart. When we start the report, if the sensor are no, it's okay. Sensor working, then we say that move forward. So if the sensor is on, sorry, if the sensor is on, again if we sensor on, then the lateral robot straight forward. If either left or both left and sensor center on to turn right, and if either right or left and both is centered on, so there is turn left. Both left and right are on, and right on, so the back to and power working same process. And then on the move forward in left and right, and then turn right, turn left. So these are this is the flowchart of working of line report. So so this is a block diagram. Now here we explain this is a Arduino Mega that we explain in upper slide. The motor driver, yeah, here we attach the motor driver with this analog pin of Arduino Mega. Now here we attach we can also say that we attach the DC motors with motor. So that's why we do DC motors, we use the two tires, so that when two DC motors is used, so two DC motors is attached to the motor drivers, and so we can for PWM check the speed of so that we encoder sensors. We use the two encoder sensors because we use two DC motors. So here this is I2C monitor, and we had where we see the LCD display. So we use here the SD card for the to storage the data, and ESP32. ESP32 is for connections for the Wi-Fi and Bluetooth data transfer from Bluetooth from Wi-Fi, and thus here we use the three sensor, IR sensor. These are the three IR sensor we detect with digital pulse and ultrasonic sensors and the interrupters. So here, now here we see here we use the voltage sensor, current sensor. So that's why we current sensor attached here, and voltage sensor is connected with the port battery 12 volts, and we also connect the voltage sensor with the analog pin because we also connect the sensor with Arduino. So as here we connect the ultrasound sensor here and the voltage sensor here, and the main the switch is attached we here, and then we attach the motor driver. So then we draw a line follower. Our line follower is sketched like this. We attach all the component like in this way. And the pin configuration is same is like that way. So now here this is a stage machine. Stage machine we explain what the this is a stage machine we make for that table, given table. Now this is the chapter 3 is about the product design. So the project system is considered for the project. Our project is based on microcontroller use, and the sensor used in our project is based on implementing logic implication. As we know for our building, we make a truth table and on his make a table and logical cost, and to save the cost elimination of the component, we define cost during the lost gates, and we explain the number of input per gates. So that's why we use the DC motors, and the DC motors was most easy to control the signals to operation. We have to change directions as reverse the polarity of the power supply, and cross it can be very speed by where the voltage across the mathematical torque is over P R W. So these are the previously, and here sorry these are here we explain the working of wheel, how it work when you move a right, and then we will how to work when you detect the obstacle, and then how it is work they like this when he was straight, and then he obstacle right and stop not working. So when he is straight and the obstacle then move over right side, and here on the right side move, and the obstacle on in this way he's moving the right side. The robot is working here, and then he says there is obstacle, then he move here, and then he move here like this. So there is explain the movement of line forward robots. This is, and then we make the table how is working. So the sensor selection for IR, we need to get the 5 IR sensors for detect the how for the path here. So this is the explanation about eye sensor, how it's work and how it operates. So here we need explain the mechanical design. We make a base like this. So we make the base on like the two tires. We also explain here mechanical. In our mechanical design, our project is about engineering our learn line for robots. In engineering project can be affected by line of parts, models, mechanical design. So we say that the mechanical report design is responsible for the rate lifting. So this is the mechanical selection, how to select the mechanical selection of the according to figure. We select about how we select about the base according to the according to movement of robot, and also about we see that we say that we also say that the report is talking about the how much is weight is loaded in our project. So these are the main features. Mechanical structure is simple. It is easy to install. The core is tachometer encoders, and with the two AM is battery box. Can be used for a distant AM velocity. Can be with other device to realize the functions for tracking obstacle, avoiding distance, testing, and speed monitor. Platform design, so there are so many design of individually can think for line for reports. Some of them is available in the markets in easy cost. This is very easy to borrow from shop because easily available in any shop. We see in the different shapes, rectangular, pentagonal shape, and rectangular. But we will take, we will using basically we are rather using the design for rectangular shape in rectangular shape. Okay. Because we are we can select the that shape for that we are feasibility of, so that's why. So we attach, we use this PCB of rectangle, and then upper we attach the PCB, and then we attach the components. So material selection, we also select in before, so which material is used for a base, ammonium, glass, plastic items, glass, and different materials we use the property of which I've selected. Okay, how much is greatest relevant. So the softwares, there's a software in design, reverse design, theoretical design. Left sensor, right sensor. Output is the left motor and right motor, SD card and schematic components with ultrasonic sensor, SD card module, servo motor, TCC RT500 IR sensor, L298 motor driver, ESP32 and 16x4. As these all these components we also show in which explain in our in the chapter number two, in chapter number two. So we can make the schematic of all these components on a Proteus, because we make the PCB of uh, the line for robot. So we are use this component. So we make the piece, the schematic of PCB uh, according to the according to the link of according to the given schematic of Sir Umar Farooq. And these are the steps, the PCB making procedure for design tool is sort design step. After they will be create over design through a user of use 2D graphic box mode and 3D press or the select layer of noise. So now here these are the explain here how to make the PCB design. As you know, we also make the PCB design in semester 3 also. So same steps we were working here. This is the truth table, that is the report is working like this. If we are using as a 3 IR sensor, then left and right the movement of reports is like this. The controller features. Okay. Now here with chapter 3 is we're starting now integration of all the components. We can write the codes. So this is the code of LCD. Now we upload the file of LCD here, and then we have set the points of here. So now this is the SD card communication modules, key descriptions and data. And this is the code. Include a file, serial communications here adds in file series, and this is the code of and this is the, we can initialize the trigger pin, echo pin, and duration of now how much is this is covered from a example. So this is a pin mode. We had trigger pin, output pin mode, void loop, digital light, trigger pin. Oh, all this now here we explain the optical encoder. These are the we can integrate or write the codes. Here, this is the code is right the Walsha. ESP32 is also right the Wi-Fi, and we had the Wi-Fi because we are connected to Wi-Fi with the our project. So that's why here we explain here. These are the about we make this uh, code. Now this is a final code. Now here we explain here how it is working. Now first of all we explain it is all about the sensors, different controller, initialize the library. Analog pin A1 voltage sensors, float volt 0, input voltage is 0, and R1 R2 sensors is 3075, its value is 0. Sensor 8 second sensors is will take time starts, and these are the floors we had explained here. Current sensor, initialize the current sensor, the pin sensitivity is 66, maximum 66 to 185 millivolts, so that's why the offsets. Now we here the inter frequency of LCD is defined the pin mode is output based on here we initialize these alphabets in the upper for the communication data. So here this is the pin modes here we write, and then we delay for low height we make the as you know we will make the truth table. According to truth table we here we add how to delay and on and off, right. When we attach the LCD, then we he moving in the movements in anywhere. So he will show the result on LCD. So this is the code is about the line for report here. This is the code of SD card. Now we make the PCB design. The main focus on the PCB design. This is the Arduino, and this is the pins which are attached here. This are the pins of a sensor which where this is the pins here we attach the motor driver with Arduino. So these are the pins we attach here. I have so see you. These are the pins we takes from Arduino we attach with a motor drivers. So that's why motor driver IR sensor. These are the IR sensor. This is the LCD 1609 voltage sensors, half refracted current sensor, and ultrasonic sensor, SD cards from metric and testometer and senior monitor making. So here this senior monitor working, we see the graph and simulation of a robot. So this is the simulink of a robot. We make the schematic circuit, and when we will run this simulink, then we see the output here in the LCD speed, voltage, current, and stop. So here this is a schematic diagram where we will see that this is the power supply we apply here, and then Arduino pins when we attach with here. This all the we can explain here block diagram. According to block diagram, we attach the sensors, voltage sensors, SD cards, all the components, remote drivers, encoders, all the components we attach according to the block diagram. So then we make this PCB Proteus on layout. Then we like that we make the monogram on Air University. So this is the Emirates name of White Robbers. Well, so right, it's White Workers. So this is the PCB design, and then we printed. Then it look like this. Then we show in the 3D visualize like this. So in when we make the picture, then we say the hardware components attached. We can see the we can attach the component according to the 3D visualization. So this is the pins. Now PCB according making the PCB challenges and the uh, what are the issues that come and challenges. The main thing is when we have made the PCB, then the line that attach the loops, then it's moving up and down, it's not be attached properly. So there's a double layer is not easy in PCB by implementing in our life. So what we do, and in the place of connection we do the robot we are doing. So if any issue in the double line PCB, so now what we do in the connection, we will send them this one layer of code made. We also face a lot of DRB and CRC errors, and also we hardening and all them that. So here this is the squares connectors. We also advise to use the square connector in place of circular connectors. But the size is 15 mm, which is not easy to implement where the roots which is very slow as a connector. So that's why we reduce the size of connectors. Then also many issues. And the chapter with hardware may implement now here you see that the PCB design. These are the sensor we attach here. So here we attach the black line on the lab, and we check the edge how it's working this hike. So this is the ESP32 attached here. This is the microcontroller PCB. This is according to PCB we attach the controller on microcontroller on the PCB attached. Rise on PCB. This is the potentiometer, and this here we see the pins, how the wires is connecting here. So now the testing implement on PCB. For PCB, we can create our final PCB layout on Stratosphere and how to implement on PCB. You should check the mirror printer on and select the output in blackboard from PCB design software and the printed driver setting. And they set the copper borders and then according to the size of layout headquarters. Now these are the points how it is working. Then next is the copper side of a copper wires. PCBs using a steel wool embrace spunk shells. Remove the top oxide layers of coppers as well as the photoresistive layers, center and surface. Also, we now the merge from the paper to sticker pattern. So here you're using a press or a petals, hold one end and keep it steady. Then you put the hot iron on the other ends for about 10 seconds. So now we have iron the photo papers all along using the tip while application. Pressure about 5 to 15 meters. Now we also then we take a plastic bag and fill it with water, and then we dissolve the 2-3 with some perchloride, and then we add the PCB into the third in this solution for 30 minutes. Then we see that this unmastered copper, so I remove it, and then the process is etching the pillars process. And then you see the process each and using the pillar to take out the PCB and check it if the entirely unmasked area has been used or out. In this case, it is leave in the solution for some time. So few drops of thinner nail polish on pitch of a cotton wool with the remove or completely toners and creates and spores. And then we finalize the PCB uh, drilling on in PCB and like a PCB driller, you have machines, you have to for all the call and the components like this. And you see that this is the PCB, and here we see here a remover of rubber copper. You can draw with black marker. We use a black marker. So there here how to this is the picture you how to solder in it. So this is the sketch how to attach the components in the PCB like this. Now in the final testing, we are final testing on this is the area we take our project like this. We can explain now. Explain that okay, we can testing the report on a lab and check the marriage on black table attached on the table, and then we make the path. So this is the average path between the straight and curved paths and testing horizons. This path is shows that 5 volts for power supply motor drive and 15 volts power supply and 15 volts power supply. All the power supply control will starting rotating and the black light path. Your hair is tapped to calibrate for black and white. Mount the Maya sensor about 1 to 2 inch above a black surface. Turn the potentiometer fully clockwise. Slowly turn the potentiometer counterwise until the signal LED is just turned. Do not change the distance between the IR sensor and the if you need to touchable the distance that need to recalibrate. The signal LEDs will be turned on when the sensor is above and white is off and it's above is black separate. After doing proper calculation, we then tested the robot and it followed the path correctly and then the testing. So this is the actual project. So here we see we complete the project like this, and the project is we attach the wiring and all the patching of the project like this. And then we see here move the project. These are the TIS sensor we attach here, and the movement of we see here the robot is move, and then is the distance between the floor and the wood is it's so less minimum. So machine like this the obstacle, so they move it, and these are the pictures. So we say when we start is that our motor driver on any working like this. So now the chapter 3 is how to manage my project management. Final bill of हमारा our final bill is material is maximum is 8,850, so much. So now and that we can complete our report. So what, how much numbers we write the letters. So this is the table of account numbers right here. The other thing is risk management. These are the these are the management of according to doing of any project in our life, and we see the main basic things. So in this project we are doing for the PCB several rise in etching carefully in etching the heat risk is when the etching is not be correctly. This makes it a very, this is a very is main issue in our PCB. Another the one other thing is the drilling is not is correctly hole on the and soldering and other things process. Right. So that's why another thing. Also, PCB was a doubly layered on PCB alignment with a big game for us. Many components will not be produced in produce, so we made it for themselves. And but in all these risks, we have to go through whether it's about material and we code excess in each pressurized environmental. So these are the challenges faced on our projects. Number of sensors. Digital IR sensor working when we doing the IR sensor, the reference minimum crash we here we see when we have a black and white surface. In simply case, we have to use the two sets ISR, but we not we detect the bar, so we use the advice to use a minimum 5 or 4 seconds. Then then this is a complexity for circuit. In this condition, two tables is very lengthy and make like a two table is very lengthy. So that's why it's very difficult to working on it. So when we take the 4 and 5 sensors. So simulation on Proteus PCB at the large extent tickling of these is not any job of the part of challenges. Was an arena track. The tracks in the project is called arena. The arena is a different type. Sometimes we have a white line with the black surface areas and sometimes the positions. So this is a component cost is so much high. That is some issue in. So these are the main issues that we should carry on building layouts in this subject. We will our study about the mechatronic embedded system. Our project is about more about understanding and dictating them. This project is let us learn the implementation of these microcontrollers in real life. We enhance our properties in symmetric on PCB layout. Making logic diagram and residual table skills will be next. We also learn about IR sensor controls, current voltage, and we may working on reuse and implement them in real lifetime. We will learn how quality of sensor factor what, how to store a data in SD card and how to display the data on this how to put something that you working while it's apart without human interface. We will also understand how to collect data from given problems and to process them, make their work and desired products. So in the 11th chapter, individual role, feedback and conclusion, we are individual projects. Here, we assign the project is program from institution information related the course. This is the course of project microcontroller embedded system. So we in this subject we learn the very things that we study the basic peak, very peak and applicable procedure for solve the problem of logical circuits by creating the logical statements. Our whole background scenarios make that our create and construct a robot which follow the line and tracks the on a specific path of line for it. So for that we use the control microcontroller, and every different sensors like current and voltage and display on see the data on all the sensors status is stored in the SD cards. So the three main procedures phase of the whole project is a circuit designing and simulation for this one is another one is simulation procedure of circuit and logic design. And the third one, last one, will PCB design. This is so and then the things we are the group members. Our group member consists of five, harboring friendly and cooperative. As you know, we are working very friendly and we are equally we are doing working on it the power pro of projects. So there this is the task performed of each member here. Creating tutorial and Excel file, software or programming contribute on the IDE for purchase files, hardware and software, PCB troubleshooting, breadboard wiring, Raul Pitney tour for component, Karachi company tours, G11 so we take the components, PCB printing and robotics, extra. In the conclusion, in the conclusion, I am explaining here okay, our robots in this project we are facing more issues, but we will solve easily by the help of Sir Umar Farooq and by the help of Ma'am Irich. Ma'am is Jaden's our lab assistants of this subject. When we solve the issues and then in this project we conclude that when the line forward report is working according to the requirement. We attach all the components with the robot and here he working according to the component like a voltage sensor current sensor he detect for we are using his voltage sensor current sensor SD cards motor drivers as ESP32 we use these components in this all this working is properly and here we just read the data and show in the LCD and we store a data on ESP32. In this conclusion, we are that we are able to now interface the sensors. We are able to we are able to interface the sensors. We are able to interface the LCD ESP32s and we are now we can easily make in easily and we can make easily and we also and we also include that the main working of robots the main task we completed the robot is moving on a black path not moving left to right only moving a black path which I carry on so our robot is working on a black path roundly so this is and now we are able to explain over we run the report on in over we run the report of line forward in a specific path. This is appendix of we are using the ESP32. We use the help of from independence ESP2 ultrasonic sensors. So this is over and these are the things which are we use here. This as the impedance of our projects. These are the links which were we taken. Okay, the data sheet and reference where we take the data and from here. So here, this is our all project. This is how the project of line forward report, how it working, how to code it, and how to is um and doing how to make it the line forward report. So this is the project of our course microcontroller.